Hello, this is Dr. Prashant Bharadwaj. Today's topic is forecasting. Forecasting is one of the most important topics in business and one of the most difficult tasks also. Forecasting is typically a marketing function, but we want to study that in operations management because every decision taken in operations pertaining to capacity, inventory, operations of service and production have a foundation in forecasting and demand. So let us discuss some basics about forecasting. So what is forecasting? Well, predicting the future. We have economic forecast, we have political forecast, we have technological forecast. Here we are looking at demand forecast. We are not looking at forecasting for our own futures. That's the cartoon here, looking at the crystal ball. Many a time businesses make decisions looking at a crystal ball, which is not a good thing. You got to base your decisions of how much to produce, how much inventory to carry, how many personnel to schedule and to hire, what kind of facilities do we need to expand. All of these decisions are based on a forecast, the prediction of how much your business can sell, products or services. Forecasting time horizons. I will not spend too much time on this, but depends on your organization, your industry, what you are trying to forecast, and so on. There are short range, medium range, long range forecast, and all these time horizons that are provided in this slide from the book are not etched in stone, because in some industries short-term forecast or short-range forecast can be up to 3 months, in some it can be up to a year, in some it can be weeks, and so on. A simple example is in the education industry that we are in, universities. A short-range forecast will be for a couple of semesters. The point is, it depends upon the industry and the business. But companies have short range, medium range, and long range forecasts. And the long range forecast is typically for new facility location, introduction of products and services, R&D, and so on. And what we are referring to in this chapter is not typically long range, it is more of medium to short range forecast, which affects the day-to-day operations. This again gives you a similar differences between short and medium and long range forecasts or forecasting realities. Axioms of forecasting are the number one. No forecast is perfect. You all see the weather forecast. Weather forecast is much more accurate than demand forecast. Demand forecast is very difficult to predict. So the first reality you have to realize is that no forecast is perfect. Does that mean you don't need to forecast? Not really. You need to forecast and later realize what kind of accuracy and later identify the accuracy of the forecast. If the forecast accuracy is poor, you know that you need to change the type of forecasting, which we'll discuss in a few minutes. But the reason this reality is important, that forecast is not perfect, is because operations managers who plan capacity, inventory, production, and service will have to understand that these decisions of capacity and inventory may have to change as and when the demand also changes from what was originally forecast. The second axiom or reality short-term forecasts are more accurate than long-term forecasts. Pretty straightforward again. What is the implication? Just like you plan looking at the weather forecast for tomorrow, whether to golf or not, whether to have the camp outing or not, with a lot of reliability. However, you don't plan such activities based on a forecast for next week. Although you get a 10-day forecast, your confidence in the forecast for next Monday is less than the confidence that you have for tomorrow. Similarly, in businesses, when you plan your capacity, inventory, and production, you have more confidence in what you plan for the near term than what you have for the longer term. The third and not so obvious reality or the axiom of forecasting is aggregate forecasts are more accurate than disaggregate forecasts. I can predict how many Toyota Camrys I can sell more accurately than how many Toyota Camry black color vehicles I would be able to sell. So when I'm talking about a specific color, specific transmission type, specific sound system, specific braking system, specific trim, it becomes more difficult to predict how much I can sell. Whereas if I aggregate everything, I will be able to forecast better. Another example, I can predict with more accuracy how many students will be enrolling in the university in 2017 than the ability to predict how many students will be majoring in operations management in 2017. So operations management is disaggregate, whereas you're talking about all the students in the university, it's an aggregate entity. So what is the implication? We can predict better how many faculty members you may need at the university than you can predict how many operations management faculty you would need. You can predict more accurately how many cars you'll be needing to produce than specific colors, specific other types of specifications within the car. So that is the reason later we will talk about delayed differentiation, which becomes critical. So these are the three axioms of forecasting. No forecast is perfect. Short-term forecasts are more accurate. Aggregate forecasts are more accurate. You will understand the implications of this in more detail later. Product life cycle is critical. Most products, like human beings, we take birth, grow, mature, decline, and leave this world at one point or the other. Same thing with the products. You have the introduction phase, growth phase, maturity phase, and the decline phase. Unlike what you see in this picture, where there is a perfect division of these four stages in the life cycle, in reality, the introduction phase may be very small, the growth phase may be very long, maturity may be short or long, and there may be a sudden decline or a slow decline. It all depends. But the idea here is, if you're Apple, you introduced iPhone 4, and you studied this very clearly. How long did the product stay in the growth phase? How much did we actually sell in the growth phase? How long did it stay in the maturity phase? If I have a good idea of all of these, good data of all of these, then when I introduce iPhone 5, 5S, and so on, I can predict how long it will stay in the introduction phase, growth phase, maturity, and decline. It may not be perfect, but it will give you a good idea for how much to produce, what capacity is required, and so on. And here you can see the different examples also in this picture. As I explained earlier, There are different types of forecasts, economic, technological, and so on. But our concern in this particular module, in this topic, is demand forecast. 7 theoretical steps in forecasting. This will become more obvious when you are looking at some techniques. Determine the use of the forecast. Why are we looking at this forecast? What are we planning for using this forecast? What are the items to be forecast? The time horizon. Select the model. We'll discuss a few models in a few minutes. Gather the data, make the forecast. Most importantly, validate and implement the results. And once you look at the errors in forecasting, go back and look at some of these methodologies differently if necessary. If the errors are minimal, then great, continue with the forecasting tool. There are 2 major approaches, methods of forecasting: qualitative and quantitative methods. Qualitative, as the name indicates, is when the situation is not clear and little data exists. You resort to intuition and experience, gut feeling, educated guesses, so on. Whereas when you have quantitative data available, you can look at the data of the past, and then using that you can predict the future. It involves mathematical tools and techniques, and we will discuss a few methodologies in both qualitative as well as quantitative techniques. The first method is Salesforce composite. This is the simplest method, the cheapest method, because you are using your internal workforce, the salespeople, to project the sales. Basically, you are getting input from all of the different salespeople who are in touch with the customers and their wants, and you take out the outliers, those who predict very low, those who predict very high, and then take the average among the rest. As simple as that. That is the Salesforce composite. Obviously, the more number of salespeople, the better it is, because you're averaging over a large number of data points. Secondly, you gotta have a matured sales force, otherwise the data that you may get may not be very accurate. Also, you gotta make sure that the salespeople are in the organization for some time, they have the experience of the industry. If you have a big turnover of salespeople, not a good idea to use this method. And also you want to make sure that sales people are not playing any games, are not being very optimistic. You don't want the salespeople to be predicting very high or very low because of commissions or any other management realities. So if you have all things equal, where the salespeople are, if you have all things good, specifically you have matured and dedicated salespeople, not playing any games, who are knowledgeable about the market, this is the cheapest and the best method, because you are getting data from people who are in touch with the customer's wants and they don't cost you anything. Those of you who are in marketing, who major in marketing, you would be taking an entire course in market research. One of the things you would do is survey the market, interview the customers, potential customers, ask them questions out of a questionnaire, and so on. Based on that and based on analysis of the data, you will be able to predict how much you will be able to sell or how many. The Delphi method is a very interesting one. It is typically used when you are predicting something new that you are offering to the market. It was used when ATM machines were introduced for the first time. It can be used when Hybrid vehicles are being used for the first time into a market. So usually technology, something new is being introduced. And the hallmark of this method is that you have experts who are hired by a decision maker. And this decision maker will hire experts, 5, 6, 8, 3, multiple experts that you think are important and who have the idea of the industry and also about forecasting and marketing research. And these experts or respondents, they go away. They're given like a month or two, and they can use their own independent methodologies and come back to the decision maker with their forecasts. And keep in mind that these respondents or experts are anonymous to each other, and they may be geographically dispersed. So each of these individuals comes back with his or her forecast using their own independent methodologies. If all of these multiple experts have the same ballpark estimate of how much we are going to sell, fantastic. You have a very good forecast. Half a dozen experts cannot all go wrong if they all come to consensus. But sometimes in this method, if you have 6 experts, 4 of them may be in consensus, whereas 2 of them may be a little off the average. They may be predicting very high or very low compared to the rest. Then you go through a second iteration after sharing the data of all the respondents with everybody. Then the respondents, the experts, go back and revisit their forecasts. They may make changes and come back with their revised forecast. So this iterative process can continue for 2, 3, 4 iterations depending upon the time available and the budget and the decision maker's decision. So after multiple iterations, even if there is no consensus, the decision maker may say that's good enough, throw out the outliers and go with the average of the rest. But typically after multiple iterations, everybody will be on the same page. That is the advantage of this method, which is multiple experts working independently in an iterative process come to consensus about the future, about the forecast. So the probability of going wrong in this is less compared to other methods, especially when you don't have previous data. You're introducing a new product or a new service. You don't use this methodology when you're doing some routine forecasting because it's expensive and time consuming. A jury of expert opinion. This is where you have very limited data from the past and time is of the essence in making a decision. So what do? You involve a small group of experts in the area and you go with the estimate, the gut feeling, the educated guess of this jury of executives or experts. And all you have to do here is be careful that there is no groupthink, that one person is dominant and everybody follows this person, for example. So if people are independent in thinking, and if this group of jurors come together and come up with a future forecast, this is another method. Again, you would not use these methods when you have past data. You would use this only when you don't have good solid data. Next, we have the quantitative approaches, basically using past data or data. And if you look at this, there are 2 types of models, time series model and associative or causal models. Time series models are exactly what it says. The past dictates the future. Whatever happened in the past is going to be the most important ingredient in this forecast. You cannot predict the future unless you know your past. That is what time series models are all about. Whereas the associative or causal models are saying that the forecast of a particular product or service depends or is caused or is associated with certain independent variables. And those independent variables which dictate the dependent variable demand can be price of the product or service. It can be the number of competitors or the competitors' prices, quality, weather, the economy, the population demographics, on and on. So what is the methodology you would use? Something we will not discuss in this class, but I assume you already know, is linear regression. Regression is where you have y, the dependent variable in this case is demand, is dependent on x1, x2, x3, which are the independent variables, which can be anything from price to weather to demographics, etc. So let us look at some of these approaches, which by no means are an exhaustive list of approaches for forecasting. These are some of the most basic ones, most commonly used also. Before that, let's look at, when you talk about time series of data, you have to look at how does your time series of data looks like. And as you can see, there are 5 different patterns of demand or components of demand here. This purple line is the dream line. If any demand is like this, and if you can show me, I can give you $100. There's no company which has a demand which looks like the purple line over time. If that is the case, you don't need to worry about operations at all, because you can plan your capacity and produce exactly the same amount every day, every week, and you have absolutely no problem. But unfortunately, most companies do not have, or no company has that. But there are some companies which have data demand which varies a little bit over time. It may not be a straight line, but you can use a straight line to depict the demand. So the demand in reality may be going around this straight line. That kind of demand is known as average. Examples of products can be toilet paper, toothpaste, milk. So these are mostly the consumer goods, fast-moving consumer goods that you would buy in a grocery store. Majority of them may have an average component, which is pretty straight, the easiest to forecast. The next type of forecast is this golden line, which is again a perfect straight line going up. It may not be that perfect, but that is called the trend. This is a positive linear trend. So smartphones can be an example of this trend. You may have negative trend also, which is constantly the product or the service demand is going down. And I'm sure each one of you listening can give an example of products that have positive trend as well as negative trend. Same with seasonality. If you look at this blue line, you have peaks and troughs, peaks and valleys, peaks, troughs. That is seasonal demand. In this blue line, you have seasonality plus a trend also. So there are 2 components in this blue line. But let's focus on seasonality. Seasonality, again, you can give an example, as many as you want, from winter jackets to swimwear to Christmas decorations to Halloween products to products which are unique to India, to China, to Australia, and so on. So these are products where you see peaks and valleys at specific intervals of time. Every summer, every December, and so on. And seasonality can be during the week also. If you have peak demand for movies or restaurants during weekends, operations managers need to plan their capacity appropriately, their workforce appropriately. So seasonality is that. And like I said earlier, this blue line has both seasonality and a trend component to it. The last one is cyclical. Cyclical is similar to seasonal because it has peaks and troughs, but unlike in seasonal, the peaks are not at regular intervals. The valleys are not at regular intervals. The peak can occur for the first time after 1 year, the second time it can be after 3 years, the third time it can be after 6 months, fourth time it can be after 4 years. Some of the products that you can think of which can fall under that category: military equipment, because military equipment sometimes depends upon other aspects like the relative stability, no wars, no other major issues happening in the region, so the need for military equipment may not be as high. Whereas whenever there is some military or political disturbances, then you will see the demand for military equipment going up. Same thing with some sports teams' attires. We are from the Pittsburgh area, so if you look at Steelers, Pittsburgh Steelers, if they are in the Super Bowl, if they're doing extremely well, all their jackets and hats and so on will be sold like hotcakes. But if they're not doing well, then the demand for their equipment will also go down. So these are the major components of demand. The reason it is important to understand this is the kind of forecasting technique that you would use will depend upon the component of demand. It will be different if it is average, it is different if it is seasonal, trend, so on. The naive approach is, as the name indicates, it is naive, don't use it, which is you assume what the demand was today would be the demand tomorrow. So as shown here, if January sales were 68 for a particular product, February sales would also be 68. Okay, it can be a good starting point, but certainly not a good point to move forward. The second one is the moving average method. Moving average is nothing but taking arithmetic means. I would look at the last n number of time periods. So if I'm currently in December, I would look at the last 3 months, November, October, September, and look at the demand, the real demand in September, October, and November, take the average of that, and then that will be my forecast for January. And when I'm done with December, I will look at the real demand in December, November, October. So I moved by a month, and I'm still taking the average of the last 3 months. So my real demand in December, November, and October, the average of that would be my forecast for February. And when I come to the end of January, I again take the average of Jan, December, and November. That will be my forecast for March. So as simple as that. And here's an example. I'm in April now. To do a 3-month moving average, all I did was take the forecast, take the real demand or actual sales in March, February, and January, and that is what I got. When I came to May, how did I get this number 13 2/3? I looked at the last 3 months, 16, 13, and 12, and I took the forecast based on the real demand of the last 3 months, and so on. So, and as you can see here, the real demand turned out to be 16 at the end of April, but at the beginning of April you thought that the forecast would be 11 2/3 or 12 or 16 to 13 2/3 or 14, but reality 19. So as you can see here, there is a constant underestimation because of the moving average here, and later we will talk the reason that is always an underestimate. Look at this data. What kind of data is this? This is a trend. If you look at the data, it's going from 10 to 12 to 13 to 16, constantly increasing. So it is a trend. And if you go back to the previous slide, you will see used if little or no trend. So when there is trend, you should not be using this moving average method ideally. Okay, that shows what I just described. The actual sales is in this golden line. The moving average forecast is in the blue line. So what kind of data is this? It's a trend. That is why you see that the forecast is always lagging the real trend. This forecast in this particular month should have been here, but it is here below. Okay, whereas this would have been ideal for this month because this is actual sales. So there is always a lag between the demand and the sales. Whereas if the demand were like this, a straight line like this, moving almost parallel to the x-axis, then the moving average methodology would work better. The weighted moving average is exactly similar to the moving average, except that you are given weights. What happened in December is more important than what happened in November, which is more important than what happened in October when you're focusing on the forecast for Jan or Feb. As simple as that. So you give weights, and based on that you will calculate the weighted average. And how are the weights assigned? Nothing scientific here, unfortunately. It is based on experience and intuition. So here, if you look at the weights, we are given the last month has a weight of 3, the previous month to that 2 months ago is 2, 3 months ago is 1. So the sum of weights is 6. So the first one gets a weight of 3 by 6, second one gets 2 by 6, the third one 1 by 6. So you can just multiply 3 times 13 plus 2 times 12 and 1 times 10, all of them divided by the total weights, which is 6, 12 1/6. You can do the same thing for the rest of the data. All you're doing, the only difference here is you're not taking 10 plus 12 plus 13, dividing it by 3, you're actually weighting them. So 13 is multiplied by the most recent month's weight, the last month, by 3, plus 12 is multiplied by 2, and so on. Potential problems with moving average. Increasing n. The most important thing here is n. In these examples we said n is equal to 3. But in reality I have worked with companies where n is equal to 52 weeks, n is equal to 24 months. So the thing here is it requires extensive historical data. If you're talking about 52 weeks of data for 2000 SKUs, stock keeping units, if you're a retail company, it's a lot of data that you're talking about. That is the disadvantage. Increasing the n smooths the forecast but makes it less sensitive to changes. Ideally, because of the law of big numbers, you want n to be big because you want to average it over a large number of data points. But unfortunately it makes it less sensitive to changes in the recent past if you take a lot of data from the past. And as we discussed earlier, they do not forecast trends very well. Same thing, as you can see, the difference between moving and weighted moving average pertaining to actual sales, They both have the same problem, that they lag the trend. Exponential smoothing is the smartest method, the most commonly used when you have average data. And the simple formula is given here. The new forecast is FT is equal to the forecast from the previous time period plus alpha times the last period's real demand minus the last period's forecast. And if you simplify that formula and factor it, you will see that forecast for the next time period, or the new forecast, is equal to alpha times the last period's demand plus 1 minus alpha times forecast for the previous time period. Very simple formula. Forecast for December is equal to alpha times demand in November plus 1 minus alpha times forecast in November. And when you go to January, this becomes December. And what is alpha? Alpha is a smoothing constant which is between 0 and 1. It can be 0.1, 0.15, 0.2, 0.9, so on. We'll see the implication of alpha in a minute. But alpha again is not scientifically determined. It is dependent on the user. His or her ability to predict what alpha is important. So look at this simple example. Predicted demand is 142 Mustangs. Actual demand is 153. Smoothing constant is 0.2. So if you'll plug into the formula on the previous page, it is pretty straightforward. So you predict to sell 144 cars in the next time period. It is a form of weighted moving average. And without going into too much detail, this formula that you saw, that the forecast for the next time period is equal to alpha times demand for this time period plus 1 minus alpha times the forecast for this time period. If you expand that algebraically, you will see that it is a pretty powerful formula. If you look at it, it looks like you're considering only what happened in the last month to forecast for the next month. It is true that you need the data only for the last month, but in reality what has happened is the demand data for the number of time periods in the past is encapsulated in that formula. So in reality you are actually considering what happened in December, November, October, September, August, on and on when you're forecasting for January, although you need only the data of December. And the formula is so nice that it is assigning weights that will decline exponentially as we go back in the past. That is why it is called exponential smoothing. So if alpha is equal to 0.1, what it's saying is the first month in the past gets 10% of the weight. The remaining 90% is distributed among many time periods in the past, and the weights decline exponentially. On the other hand, if I make alpha is equal to 0.9, I am saying 90% of the weight is given to the most recent demand data. Only the remaining 10% is distributed exponentially to the few time periods in the past. We'll see that in the next picture. So smoothing constant alpha goes from 0 to 1. It is subjective, like I said earlier. And the most important thing about exponential smoothing, although it considers a lot of time periods in the past while forecasting, it involves little record keeping. It literally requires only one time period's data. Now look at the effect of the smoothing constants. If alpha is equal to 0.1, the most recent period gets 10%. The second most period gets 9% of weight, 8.1, 7.3, 6.6. On the other hand, if alpha is 0.5, the most recent period gets 50% of the weight. So it's up to you to decide. If what happens in the most recent period is extremely important, you take alpha is equal to a high number. 0.9, like I said, 90% of the weight is given to the first or the most recent period. But if you think that what happened in the most recent period is not significantly more important than what happened in the second, third, fourth, fifth, then I would use a small alpha, which shows here that the most recent period gets 10%, then 9, 8, 7, 6.6, and so on. The key here is that you don't need to worry about all of these. All you need to do is pick an alpha which will automatically assign the weights to all of these time periods just by using that simple formula that we looked at a couple of slides back, which is the forecast for the next time period is equal to alpha times demand for the current time period plus 1 minus alpha times the forecast for the current time period. This shows the same thing in a graphical format. Again, what we discussed were only a couple of types of forecasting tools. There are many other tools which we will talk about in a more advanced class. This should at least give you an idea of how forecasting is done. Now, like I said in the very first few slides, the first axiom of forecasting is no forecast is perfect, but you need to measure the error of forecast. So there are a few ways to measure forecasting errors. One is MAD, which is mean absolute deviation, and the names indicate exactly what they are. You take the deviation between actual demand and the forecast, take the absolute value, and then take the mean or the average. Okay, sigma is a summation divided by n gives you the average. Mean squared error is another measure, which is nothing but the variance. So you take the forecast errors, which is actual minus forecast, square them, and then take the average. Mean absolute percent error. This is an important measure which puts the error in perspective, where you take the actual and forecast difference, take the absolute value, and then take the percentage error, and then take the mean or the average. So what this does is it tells you whether the error is 1%, 2%, or 15 or 20%. So if it is 15, 20, 25%, you know there is a problem. If it is 1, 2%, it's acceptable, for example. So the mean absolute percent error puts the error in perspective. Other forecasting methods: exponential smoothing with trend adjustment, least square methods, seasonal methods, regression, on and on. There are many other methods that are not listed here, but we will skip it for an advanced class. How do you monitor and control forecasts? Like we just talked about, you look at errors. But when you're looking at thousands of products, you cannot do it manually or physically. Identify when there is a problem. So what do? You come up with tracking signals which automatically determines whether the error is within permissible limits or not. So what do? You take the ratio of the running sum of forecast errors to mean absolute deviation. So you find out what is the difference between the forecast and the demand, that is, and take the cumulative value, that is the running sum, divide that by the MAD, and what happens next is you put that on a graph. Automatically, if you see this, where look at this part of the graph, so it is up, below, so it is going randomly in between the upper control limit and the lower control limit. But the moment the ratio of RSFE to MAD is beyond the upper control limit, as you see here, then there is a signal. You are tracking it and then signaling to the user that there is a problem because the difference between the forecast and the demand is not within the acceptable range. You will also alert the user if you see data points all on this line, for example. Even though they are within the range, there is a pattern if all of them are above here, or if you see all of them below here, or if you see a straight line like this. So the point is there should be no pattern within. As long as they are within the control limits and not having a pattern, we call that a random error. But the moment you see data points beyond the acceptable range, or if you see data points all near the upper control limit, near the lower control limit, or having a trend, then you see that there is a bias error, which means there is a specific reason for that to happen. Focus forecasting was developed by Mr. Smith in American Hardware Supply, and it is based on the principles listed here, that no matter how sophisticated the forecasting model is, you cannot be assured of a highly predictable model. Secondly, it also says that there is no single technique that is ideal for all products and services. So what this company did is pretty unscientific, but many followers are there for this methodology, which is basically use the historical data and try out multiple models, moving average with n is equal to 3, 4, 5, 6, so on, alpha of 0.1, 2, 3 for exponential forecasting, and many other methodologies. If you are good in Excel, if I give you a piece of data, you should be able to use all of these methodologies and tell me what the forecast would be. That is exactly what this company does. So if you are in December, I take the demand of January to December and use multiple techniques of forecasting and forecast for January. At the end of January, I find out which one of these multiple methods was the one with the least error. That was the best method. Whether I used it or not, I use it for February to forecast. In addition to using the best method in January, I again use all the multiple methods to forecast for Feb. And at the end of Feb, I find out which one was the best method that worked for Feb. I use that for March. And again, forecast using all the other techniques just to check which one was the best for March. So the whole process continues. Basically, you're using multiple models and then picking the model which works the best, and that model may be different for each month. That is focus forecasting. Forecasting in the service sector, there are some unusual challenges there. You will have to make sure that you cover for holidays and calendar events. In retail sector, in service sector, and the capacity constraint required here may be different. For example, if you're talking about a hospital, it is not just the number of beds that are important. You have to look at the capacity in the emergency room, capacity in the operation theaters, on and on.